Section 5.7 will talk about the inverse of trigonometric functions. So we know that in order to have an inverse for a function, the function itself needs to be one-to-one. However, for trigonometric functions, we can't have that because, as we know, trigonometrical functions are oscillating between different values. So they have more than one value for, let's say, for one y, we can have many x's or many x's that can give us the same y. However, we can still have inverse functions or inverse trigonometrical functions if we were to reduce the domain of our function. Let's say, for instance, if we are talking about the sine, we can still have an inverse for the sine between minus pi over 2 and pi over 2. And that's what is shown here. They said that every trigonometrical function that we know can have an inverse in a certain range. So, for instance, as I said before, for the sine, we can have an inverse function which is called arcsine, where the range is between minus pi over 2 and pi over 2. For minus pi over 2 and pi over 2 is for the, let's say, the range of the values that the arcsine covers. However, for the domain is surely between minus 1 and 1, because again the arcsine is the inverse of sine. So if sine is between minus pi over 2 and pi over 2, then the arcsine should needs to be between minus 1 and 1. They also say that there is also arc cosine for the cosine, which domain is between minus 1 and 1 again, because the cosine needs to be defined between 0 and pi to have an inverse. For the arctangent, it's the inverse of tangent, and its domain is minus infinity to plus infinity. So any real number can have its we can have the arctangent of any real number, because the tangent needs to be in order to have an inverse, which is the arctangent. The tangent needs to be defined between minus pi over 2 and pi over 2. Same for arccotangent and arcsecant. For arcsecant, the range of values that we can have is between, or rather, the absolute value of x needs to be greater than 1. Why is that? Because for secant, which is 1 over cosine, the cosine needs to be different than 0. So the values needs to be between 0 and pi, except for pi over 2. So we need to take that into consideration when putting the absolute value. So x can either be greater or equal than 0, or less or equal than minus 1. So x, as I said, since it's in absolute value, then it's either greater than 1 or less than minus 1. In the case less or equal here. So for the arc cosecant, it's the same again. So it's either x should be either greater than 1 or less than minus 1, since the values for y are between minus pi over 2 and pi over 2. Some properties of the inverse of trigonometrical functions are the following. So if we have x between minus 1 and 1, which means that y will be between minus pi over 2 and pi over 2, then we can have that, we can see that the sine of arcsine is equal to x, and the arcsine of sine of y is just y. Why is that? Because again, arcsine is just the inverse of sine. Same for the case of tangent, and same for the case of secant. This also holds for the other inverse trigonometrical functions, such as cosine, arccosine, and arccotangent, and arccosecant. Now we can move on to the derivatives of inverse trigonometric functions, which are the following. So in the case of arcsine of u, we'll end up with u prime over the square root of 1 minus u squared. Whereas for the case of arc cosine, we just add a negative sign here. It's the same again for arc between arctangent and cotangent, we just add a minus. And same for arcsecant and arccosecant, we just add again minus. So in case you want to remember these derivatives, you just need to remember these here, and then you just add minus signs to get the other ones. There is also mention of what we call elementary functions, which are functions or which are the following functions that we are going to see now. So they say that these functions here are enough in order to define any problem, physical problem or chemical problem or biological problem, any problem, whichever we can think of, we can solve it using one of these functions here, which we called again elementary functions. What are these functions here? Which they are polynomials, rational functions, functions involving radicals, and by radicals I mean the square root, which means square root functions. Then we talk about the transcendental functions, which are logarithmic functions, exponential functions, trigonometric functions, and their inverse.